Bivariate analysis. Bivariate analysis is statistical analysis involving simultaneous measurement of two variables. So bivariate data, when we dealing with two samples in one observation, we says that the data is the bivariate. So one is the thing which we are discussed here, a correlation coefficient, a numeric measurement of the linear relationship between two sets of measurement made on the same set of subject. It is known as Pearson product moment correlation coefficient, and it is denoted by the letter R, and the value is from -1 to +1. The value of +1 denoted that the two sets are perfectly related in the positive sense, and a value of -1 indicate that the two sets are perfectly related in a negative sense. A value closer to 0 indicate that there are no linearly related. So here is some data. So this data is 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3. See that this are in line perfectly positive, and here are some data are displayed. So 0.2, 0.1, 0, there is no correlation, and here is the -6, and also here is the -9. So that's are related to a coefficient, correlation coefficient. Now we see the another example. The example so this data is one is the height, and height in centimeter, and pulse is pulse in bits per second, bits per minute. So centimeter and bits per minute. So we check the is there any relation between height and pulse. So there are two data samples. There are two criteria which we take from the bivariate data. Now we first we see is there any relation between two variables. We just plot the scattered plot. So scattered plot, we go to the, just close it, we go to the graph, task, graph, scatter plot, task, graph, scatter plot. take two-dimensional scatter plot, and the data, take the height to horizontal and pulse to vertical, and then run. Scatter plot is very important to know about the relation of two variables. Just correct this one, modify it. Now the data point maker, we select dot. Okay, we run it. So here we got all our two variables at scatter plot. Here is some important information. We must make the scatter plot because sometimes we check visually, we check is there any relation between two variables. So here is like we see that here is one little bit relationship between height and pulse. Uh, if it means there is some value or uh, correlation coefficient, but uh, if the correlation is the correlation coefficient is 0, it means there are no relation. But sometimes is there any graph like this one U shape and this like curve one. So in that case we also see that the correlation coefficient is 0, uh, but there is another relation, not a correlation, but there is another relation. So we must check through the scatter plot. We can identify is there any relation between these two variables. So now we find out the correlation coefficient between two variables. Now select the data, and now we are finding the correlation coefficient. See here, task, multivariate, correlations, task, multivariate correlations. We have two variable, height and pulse. We said we just select that one or both analysis variable. So we found out the correlation coefficient. Still working. Now we get here the data. Our data shows that the correlation coefficient is 0.21, and here 0.21 means that there is some positive relationship exists between two variables. Now we just analyze another another method, and we just go to task, regression, linear regression, task, regression, linear regression. So under data, we have two variables. The pulse is the dependent variable and height is ex explanatory variable or independent variable. Now we run this program. The process still running. Congregation. See the status bar at the bottom. Regression, running regression, running linear regression. Now we get another analysis of variance and also the p-values. The p-values here 0.127, and also the parameter is 0.27. Now we take another analysis through this one. Use linear regression. Just reopen, modify this one. See, here is the plot. So select in the plot, select custom list of plot observed as independent. Observed by predictor value plot 1, and we select confidence limit. We can select just again we running model statistics plot. Now it's running. So here is the graph, and one, just select one more thing. Go to the modify linear relationship. Go to programs, ANOVA linear models. So analysis variables are both modes. Just make all graph. There is the show the linear relationship. Open data. Here is the two columns. First is O2 in and air out. Oxygen in and air out. That's the expire ventilation. So oxygen uptake and air out. We can draw the plot, scattered plot. To see the result. Oxygen take horizontal and vertical on this. So it seems that there is some relation, positive relation. Now we find out it by the coefficient. So multivariate, task, multivariate or correlation. Multivariate, task, multivariate correlations. We find the correlation. We check both variables. So there is 0.95 and 0.9 means there is a strong correlation between the two variables. Now take another example for the bivariate data. Open data. This example from the health science. Here are 53 observations which is one column 1 is oxygen in and air out. This is the data of all health science. So now we just going to plot it to see the behavior of the data. Now plot. Now first we plot scattered plot. Oxygen out in on horizontal, oxygen out, air out on vertical, oxygen in horizontal. Now plot this graph, scattered plot. Now see, here is the plot of is the strong relationship. So that's not a linear, because it's not show the straight line, it's like curve. So it have the data have a strong relationship, but it's a non-linear. So now we see how what is the coefficient correlation coefficient. So go multivariate correlations, analysis variable is here out, both are the analysis variable. Now run this one. Now here is correlation coefficient value is 0.95, and the p value is very minimum, 0.0001. So this 0.95 shows that this is the strong relationship among the variable, and the p-value is very little, means that we do not have any, this is the non-linear. So now we just going to plot of that one. Select the data, task is a linear regression. Now first we check the linear regression. So the dependent variable is air out and independent exploratory variable is the oxygen in. Now run the graph. Now run the query. So here I'll just create all the graph residual. Open the data. US birth. Here is the data of birth per thousand from 1942 1947, and here is the birth rate. In this data we would like to explore the data for any interesting patterns that may tell a story about the data. So we just go to change the column name, this one, open query builder, change column name, births, birth ratio, ratio to birth, we run the queries. Now here is we change the column birth, a new name is birth. So now we analyze the time series data. So go to the analyze and go to the task, time series, and prepare time series data. Task, time series, prepare time series data. Here is it's automatically selected, just deselected it here. New time ID, drag here is the time variable. we just rename is here to month, and the month is starting from one 1940. Monthly interval is correct, and we just bring birth to time series variable. Now click run. Job is running. Paper time series data running. See status. Now we get the month and the birth, means birth ratio. We plot this one to see the detail of that one. So task graph, scatter plot, select the data. Month is horizontal, it's time data, and vertical is the analysis variable, and appearance is dot. Now run this graph. Now we see the graph of a scattered plot. We've seen some relationship here. Now to see the more closer to this graph, just seeing the modify this scatter plot. Click on chart area, specify the width. Width is 600 and height takes 200. And go to the appearance. Pixel width pixel is select 3 points. Click run. Okay. The new plot displays many peaks and thoughts and suggests perhaps some minor within a year trend in the additional to the global trend. A clear picture is obtained by plotting only a part of the data. Here will be plot the observation from the year 1940 to 43. To do this, we begin to create a filter to include only data for the year 1940 to 43. Close it first. Select the data, query builder, filter data, month. We select less than value, select from here, filter, month, less than, we want to select the January 1st, okay, okay. Now we get the data to December 1943. So plot this data, graph, line plot, data, horizontal, month, vertical, birth, appearance, this is okay, chart area, width 600, height 200, click run. Now we get the data from 3 years data, 40 to 44. Now if we want to do the whole plot, We select this data, select this data, line chart, same as this one, appearance, data, line chart, 600, width 200, data, month, horizontal, birth, vertical, same thing, or on this one. So we get the data till 1947.